Good morning.
Morning, how are you?
I'm good. How are you?
All right. So how have things been going with you?
Good. Busy, but feel more settled now.
Oh, good. Yeah, have you been moving or?
Yeah, moving
Okay,
into a house that I own.
Oh, okay.
But some work. Yeah, all is well.
Good. Yeah, that's great.
How have you been?
Pretty good. I'm doing all right. Yeah, been busy with all sorts of things. So.
Yeah, how's the all the summer stuff going?
Oh yeah, pretty good.
Because it's been like a few months since I've been here.
Yeah, well, yeah, we're doing the Google Summer of Code, and we're doing the working on some papers and teaching and everything. So I'm pretty busy. And then we've been taking a break from the cognition futures in the cybernetics group. So, but we picked up a meeting in open source, so balances out, I guess.
Yeah, I should be able to do both of those groups this week.
Okay, that's good. Yeah.
I guess I don't know what Jesse wants to do with cognition futures, but if people are available and have the time and energy, I can lead the cybernetics one on Thursday.
Yeah, I think that'd be great. Yeah, get back into it. So yeah, great. So I'm glad you're doing well. Well, Sarrah?
Yeah, so I don't really have any updates for like things I've been working on because I've been working on things that have nothing to do with the group.
Yeah. Well, that's good. Yeah.
I bought some books.
Oh, okay, good.
I've just continued to download some papers, but that's it.
Yeah. Well, we all download papers, so. Well, Sarrah and Morgan and Jesse.
Good morning.
Morning. All right. So yeah, I was just catching up with Amanda. She's been busy, and she's kind of in the back in the loop. So, we'll be probably doing cybernetics reading group this Thursday. We had a good Diva Worm last week, and we'll have one again this week. And then we've got our open source meetings that are going on, and those are going well. And so, yeah. And so I don't know if we want to do updates. I know Amanda said she didn't really have an update, obviously. But if we have other updates from other people, now's the time.
Well, go ahead, Sarah.
Yeah. No, I was just gonna say. I mean, I gave most of my open source project updates yesterday, so I'm kind of working on the agent-based model. But then there was this one paper that Morgan had also forwarded to me, and Jesse had also talked about in the Google Summer of Code channel. So it was a paper that I'd read like long ago, but I haven't talked about it much in regards with my project because like it was not that relevant. I found a more relevant one. But I and that is a paper that I could like discuss in today's meeting.
Yeah, it'd be good. Yeah. Why don't we do that after updates and we can talk about it?
Yeah, sure. Okay. So yeah, and yeah, the Summer of Code updates. I mean, they're like I don't think that relevant here, but I'm working on them.
Oh, good. All right. So Morgan?
Well, I just wanted to give the update that Celsius, the community biolab in San Francisco, finished its How to Grow Almost Anything course.
Okay.
And this is great. Well, I think lots was learned along the way, as well as it was good to identify the kind of equipment that we need to be able to do the full MIT course. So this is like a intro to synthetic bio course. But really good news in terms of the amount of money it brought in, the people that came as students, and then ended up, contributing to the biolab. Yeah, so it's really great. Like I think we're looking at some places that we might be able to get a lease on, get our own space as opposed to using kind of a co-working lab space. But that's kind of cool. There's lots of great papers out there, especially in computational psychiatry, in kind of precision medicine in particular. Liam Williams' lab in Stanford's got a really interesting paper, but I'm sure we got plenty to talk about.
Yeah. Yeah, thanks, Morgan, for that update. How about Jesse? How are you?
Hey, okay, I'm a lot. Yesterday was funny because I intended to be sitting at a cafe and having a nice chat much of yesterday, and that was totally disrupted by the NBA championship parade in Boston. I kind of ended up walking like directly through it to get to where I needed to go, and the parade itself moved much faster than expected. So it's kind of funny. It was sort of like unintentionally being filtered into the, choke pointed into it.
Oh,
Eventually, and I was just like, okay, but it was fun. Beyond that, what's the real update? I'm finally into a summer period. It's the finals are done, and this week has been both interesting in that sense, and also there was kind of this. I don't know. I know Boston isn't the hottest place in the country, and people who dealt with heat wave all over the country and stuff. But the way the heat wave was here, it really was a shutdown. So for like 3 days this week, there really wasn't a lot to do, which was, I guess, nice, but also a little bit frustrating because I'm kind of dealing with this. Okay, now I get to work on all my projects. Like when you kind of start hanging around the academic people and the professors and stuff, they get excited for the summer because, okay, now I get to focus on what I want to do, and it's different from when you're like a younger student. Like, oh, it's summer, I get to do nothing, I get to do whatever, I get to whatever, go away, and it's a bit of that vibe. There's a number of things, and also I kind of wanted to comment a little bit on what became of the research management Slack thread.
oh yeah.
We can get to that later. Like what's emerging there is good, but there's sort of I think it kind of, has brought about I guess people wanted to have those kinds of discussions, but it's also kind of funny because like the way some conversations have emerged were, I don't know. I don't have any comment on that fully. I'll come back to that later. But
Okay.
let's take for general updates for now. So general updates for this week. I'm basically trying to plan out the summer. What do I want to do basically between now and September 1st? Because there's a lot going on for me. There's some things I'm trying to follow up with at UCSD. There's a lot in terms of, I think I did a very kind of typically unstructured and not very clear discussion, I think last Friday, about NLP and the quest of, I was saying how I appreciate the last 2 weeks of the NLP course were actually about ethics and moral bias, which is a specific thing, and then ways of mitigating bias. And we did the final project for that course had to do with, look at a paper attempting to mitigate bias, and the sort of tension between NLP as a field of study and how much is that field of study engaging with these subdisciplines that are making these their models and databases and data sets that are subject to NLP and so on. And I really appreciated that, and I think that is an interesting. One of my biggest takeaways from this term, unexpectedly or unintentionally, is sort of what it's sort of, I don't know what to call it. Like, I kind of want to use this word that's essentially something like data strategy, because it's not quite ethics and it's not quite, fairness and accountability. Like, those are all related terms. It's not quite like data science. There's the data science of doing the things like the process of data, the process of cleaning the data, the process of building the model, testing the model, all that stuff. Like that's all, part of it. But there's also this strategic element that's emerged from both that's come about maybe most explicitly in what was the data ethics course, which is sort of makes sense. But like I've said, that course has sort of been the most applied course in a lot of ways, even though it's maybe one of the lesser technical courses. It's sort of the most applied in terms of the actual communication and strategy. How do we talk about this? How do we communicate? How do we identify? How do we sort of deal with the philosophy or the applied interactions and the choices? So between that and the NLP course, it's been really, I'm at a very different vantage point, or I'm at a new vantage point in terms of like what can be done in these spaces. So a lot of things are swirling in the arena of society, ethics, technology. A lot of things are swirling. I did the NLP bias paper focused on mental health space topic, about associations for like gender is a very common bias in NLP things and associations, but then like sort of gender plus mental health and like both receiving health or receiving care or feelings about people with mental health conditions. That was the basically reviewing a paper on that, and it wasn't anything groundbreaking, but it was sort of a nice example of, okay, here's trying to do sort of intersectional or complicated takes on bias that's more than just one feature. But so the vantage point that I'm from now is, okay, what can I do to sort of take some of the things we've been looking at in society ethics technology for a while, and how can quote unquote data science, or maybe this thing that I'm talking about is data strategy or data science strategy or something of that nature, and do more things with it, or like refine or bring out of conceptual phases into more kind of creating these analytical tools around them. That's a new vantage point that I really haven't had before as sort of one update. There also is a lot of things going on for Joe Pro, and some things potentially happening for Twisters. Plot Twisters, unfortunately, I don't know what to say yet, and really want to be able to say more and do more, but it's kind of to be determined. But there's a lot of potential. I had to sideline doing it, but maybe I should post the Inclusive Gaming Conference post this week. I never really put that in the medium or anything like that. And that's, as I said, that's been a huge event, because I've been following a number of people from it. We have people from, I think Chloe Chanel was one of the panelists, and she works at, I think, a place called Player Research, and there's a number of, she has a blog, she has her group, which I believe is about sort of what it sounds like, people interacting with video games, players and stuff like that, or people using devices. She has a blog series on incorporating sort of more modern and inclusive practices into like how to run an organization, or how to run it's not there's a software development, but a development company, different ways of doing that fit some of the ethos of the inclusive gaming commons, but also things that we're talking about here in terms of open source, running an open source team, or the thing, sort of a different take in what is happening in open source communities, or what could happen in open source communities, not necessarily at the level of interacting with the files on GitHub we're talking about on the project, but other foundational components and how these things are working. I think that's a really interesting an important space to be in, and part of the things that I do want to continue to talk about in maybe, let's say, the research management channel, which again we'll talk about that later. That's one. The outcome from that event continues to be really strong and powerful. I didn't get to look at this, but one of the other people who was there is reading about funding for all sorts of assistive technology happening in Europe, and the update, just kind of seeing the updates of what this person's doing is very useful. No less like Amanda Curtis, who's sort of Plushers is affiliated, but a major organizer at the event has been doing a lot of really cool research, and is doing something with one of my other friends participated in I think it was Zelda, one of the later Zelda games as the center for her research, and just getting unexpectedly the way that the different research, basically what I hoped is true, like seeing everybody at the event doing their actual normal research and projects is really fueling quite a lot of things. So some future plans for that are like, I might invite people to talk here, or I might try to do some collaboratory things here with that. I know Orthogonal Lab doesn't do a whole lot in that sense directly, but I mean, we have people working on 3D environments. We have people working on, people in the industry and similar spaces, and doing ed tech related stuff and all this stuff. So there's a lot there, and I continue to be excited about that. And briefly, my last general update is I haven't done labor under the Joe Pro banner directly for basically 3 weeks. The whole finals period, I didn't get to do anything that month. But my some goals I'm having there are finishing updating the website and finishing updating the structure of some of the working groups, including the mental health working group. And Jen is doing a lot there, and I really appreciate that. She's sort of aiming to do some social work, masters of social work related things, but also for those who aren't familiar with social work, there's sort of an interesting and difficult divide at the training level between micro and macro social work, or like theory and policy versus like having a clinical practice. And so that's been a very interesting space I have friends who have actually gone through it, but now it's like I get to be much closer to hearing what it's like as someone's choosing where to go and what to do and what programs are out there. And actually, University of Michigan has a very nice like online like Coursera type intro program that has like going through that, what's it like, how are they talking about these things. So the mental health working group is coming along. There's also it's been interesting to talk about the movie Inside Out. There's Inside Out 2 that came out. I actually saw that. And that's sort of built around a psychology emotional model, like internal family systems, IFS. and it's you know it's a movie, and it's a movie for kids, and we can talk about it at some point. Not really for kids, I should say, but it's sort of aimed at that. I actually really like the first one. The second one, we'll see, but it's sort of these accessible models of talking about emotion, of talking about structure, of talking about modeling other people's situations and their emotional drivers is interesting. That's a little bit of a certain flavor of things, but otherwise there's a lot of things that might fall into the DSM project is still ongoing, and I'm basically kind of bridging that under the I don't know, banners of somewhat cognition futures, but also I think it's also well housed in what the working group is fleshing out to be about. So yeah, that's a pretty broad smattering of updates, but I will turn the mic back over to you all unless there's other questions you have about that.
All right. Yeah. So thank you for the update. Paola said, "Hello, everyone. What is the event Jess is talking about?" I think he was talking about plot twisters, right?
I mentioned a whole bunch of things, so I have no idea what.
But I think that's when it happened. So when she asked.
Yeah, plot twisters isn't an event for what it's worth. It's a group.
Oh.
But,
well, I mean the Inclusive Gaming Conference, I guess.
Oh.
So yeah, okay. Yeah, so that's good. So I guess Hussain and Paola are here. Welcome. Did you have any updates?
Yeah, so I had just spoken the other day. Happy to reiterate some things. Is okay. I mean, I guess I can share. No problem.
Right.
Yeah. So I just spoke the other day during the open source meetings. So I guess Amanda and Paula weren't there. So with regards to the breast cancer community demography approach, yeah, Dick and I have been making some good progress. And oh yeah, maybe Jesse wasn't there the other day too. I'm not sure if Jesse was here yesterday, but yeah, we're moving more into the excuse me, we're moving pretty steadily into the simulation side of things and having a lot of strong discussions on how to best adjust the geometry of these methods of steering X-rays with respect to the Janospheres to see how well and how closely they can be refined to basically make the experience as best as they can for everybody involved. And a lot of it really comes down to understanding the best ways to compress the breast and figure out the geometry, the math, and the physics to optimize it with respect to the current hardware technology we're using. So yeah, it takes a lot of work, a lot of very technical, thorough discussions, but a lot of it is very, very, very exciting. So like we've been talking about. So yeah.
Great. Yeah, thanks. Yeah, so, and then we also want to talk about this research discussions channel, or what is it called? Research management channel on Slack, but we'll do that in a little bit, and that involves a couple people. So, but Sarrah, I wondered if you wanted to give your presentation on the paper.
Yeah, so the Generative Agents paper, basically I had come across this quite early on when I was just kind of trying to learn more about agent-based modeling and trying to do agent-based modeling and results using LLMs. So this is one of the great papers that kind of gave a very nice. They achieved very nice results with it, and then also recently, quite a people shared this paper on Slack. So I thought I'll go through it. So basically, what it does is they've just kind of tried to simulate an entire human world, like a small town, basically, where there is a school, there is a cafe, there is an election at some point. So it's basically everything that would happen in a real life world, and they've taken inspiration from the Sims game. And what they've done is like there are 25 agents in this town. Each agent is powered by an LLM, and they just kind of let those agents run wild, and they've observed very specific, like very human characteristic behaviors come out of these agents. And then like there's a very specific architecture kind of to how they've done it. So yeah, basically they're introducing generative agents as computational software agents that simulate believable behavior, where they can do all these different tasks: waking up, cooking breakfast, talking to each other. And because they talk to each other, it's like they form opinions and notice each other, and they can also have conversations. But not just have conversations, but then they can like remember and reflect on those conversations to be able to form opinions and do other, like continue the entire cycle. So it's not like very short lived in that sense. So basically the main contribution of the paper is this like architecture, where like it's not just a large language model. It is a large language model combined with the ability to store the agent's experience, basically the memory of it. So kind of like have a memory structure. Then they've also come up with a really clever way to synthesize those basic memories, which are like kind of in a log format, to higher level reflections, which is what enabled the very human-like behaviors to emerge. And based on these reflections, they also have the ability to retrieve the reflections to be able to plan what the next behavior should be. So yeah, the sandbox environment that I described above, it's based on the cells. And they've given examples. So yeah, basically like the three main things that they've kind of simulated, contributed is so the first one is the fact that there is the memory stream, which is like this long-term memory module, which can store a lot of memory. So I still remember that like when I was looking through this paper and I looked through their code as well. So in this paper they exclusively use the GPT-4 model. The GPT-4 model has a 128K context length, which is why basically these LLMs are able to remember a huge chunk of prior information whenever they're trying to make any new inference. So it's very like similar to the human sense in that. And then so the first is this memory stream, where they just kind of store everything that they go through, like whatever is happening in the environment, whatever the agent is going through, all of the experiences. Coupled with this memory stream is this memory retrieval model. I'll talk about it later. That this is quite a unique contribution. It's RAG, retrieval augmented generation, done in a very specific way for their architecture. And then the next is reflection. So like the first is memory stream. The next is they give these models specific prompts that allow them to look back at the memories and get insights from them. And basically that is how they can draw conclusions. And then the third is planning, which is like they kind of look at all the relevant information they have and try to plan their whole day out and then execute that plan. So yeah, it's basically like they're trying to create social role play scenarios. And yeah, so like they also described a lot of related work. I'll skip that right now, and I'll go into how their model actually works. So they've created this their own basically game world, kind of sandbox world called Smallville. It has these agents in it, and so the first is like they kind of give these agents each of these agents a very specific description. So even in their code, like they have one whole JSON file for each agent's background information. So it's like this description where basically they describe what the agent does, who he likes, what his hobbies are, who are the important people in his life, like his wife, son. They describe the relationships. And like all of this goes into like the basic description file. And what it does is basically every time the agent is going to make a new inference or going to make a new observation or anything, this entire description will be there in the context of the prompt. So basically, it's like no two agents, even though they will have the same LLMs powering them, no two agents will behave the same way. They will behave based on this description that they have. That the LLM believes that it is John Lynn, and it will behave like John. So basically, yeah, everything goes into the agent's initial memory at the very start from this description. Then they've described like I believe two types of communication. So the first is agent-agent communication or inter-agent communication. Basically, it's like at every given time, like at every time step, the agent puts out a statement of what they are currently doing, like writing in the journal or talking with the family. And then this is kind of translated one into movements in the world. So if the agent says that I'm going to bed, then in the visualization also the agent will go to bed. And also there's like this basically like they use this to communicate with each other as well. So basically all of this that they like at every time step, the statement that they evoke kind of goes into a global memory log. So the other agents who are nearby will know what this agent is doing. And then if they want to have external communication, they talk to each other. So as I said, they're aware of other agents in the local area. And whenever they walk by, they can engage in conversation, like statistically, probabilistically determined. And then if they do talk, then they just basically use like proper natural language. And the next is like the user can also kind of communicate with the agent in natural language by the persona. So basically like the user can kind of become the the original description prompt that I talked about. So it will kind of get entered there. And then so this was like agent communication, and then there is how the agents will interact with the environment. So basically there is this like the movements are controlled by their natural language thoughts that they have. And there will be a user controlled agent also, which they will just treat as a normal agent. And yeah, basically they can influence the state of the objects, like just like at every time step, every agent will say what it is doing, like it is getting ready for bed or it is getting ready to eat. There are various objects also, like refrigerator or whatever. And then those things will also have their like states, kind of, if it is full or empty, and even that will get translated to natural language at every time step. So it can be idle, or it can be full, or it can be empty, and those also keep getting contributed to the logs, so that way the agents kind of know. So basically, like, just as if this is the state, then it gets converted into a natural language, and then the agent can notice this because it gets stored in the log. So that's how like the agent interacts with the environment. It's all via natural language. There's no other like sensory input here. And then there's like this basic example that they've given, which is like the So along with the description, there's also kind of like a basic morning routine that they kind of start off each agent with, which like you wake up, they take a shower, gets dressed, whatever. And then the agent starts interacting with the other agents. And so now like this is an example where they illustrate how their working starts, where like they can recall the previous conversation. Like if they had a conversation here about the son saying that he's working on a new music composition, the dad can then tell the same thing to the mom that he's working on this music composition based on the memory that it has stored. And then is like how the actual social behaviors that are emerging. So the only program thing is the kind of description or the background story we can say of each agent, and a kind of a basic routine that they will follow, like if it's a student, they'll wake up, go to school, etc. These are the things given in the prompt. But then there are a lot of emergent social behaviors, like exchanging information with agents that are nearby, forming relationships if those conversations are nice, and also coordination among agents. So these are not like pre-programmed. They're not told to do this exactly. They are said they can do this, and like these social behaviors are observed. So basically, like they notice in their experiments that as these agents notice each other, they're in the same local this. So in this sense, like even though we are viewing a visualization of the agents being close together, the only way these LLM agents will realize they're close together is they'll be able to hear the outputs given out by the other agent. So once they realize that they're close, they can choose to engage in dialogue. And once they engage in dialogue, they can basically spread information. Like what is stored in one agent's memory, via conversation, that information will go to some other agent's memory. So a great example that they give here is about an election. Like there is one agent who decides to run for mayor, talks about it to one person, and then later after the person was going to stand in the election leaves, the other two people talk about his candidacy in the election, and soon it basically becomes a talk of the town. And like it's kind of a very like human thing of how something important or something like gossip will kind of spread very quickly because everyone will be talking about it. And then the next is the relationship memory. Like basically there'll be some basic relationships defined at the start, like a wife and a son, but they will also form new relationships over time. They will do this by remembering their interactions, and if they have many interactions, they'll remember what the other person does, and slowly it will be more and more like much like human life, where they'll have more memory of the other person. And then they also noticed that they coordinate with each other. Like if there is a party going to happen, so if there is one person who has taken the responsibility to decorate, but if that person asks for another person's help in decorating, then the other agent can agree. They will actually plan out that at this time I have to go help this other person, and they will kind of come and help. So basically these are the social behaviors that they like kind of again observe, like spreading the word of something, decorating, even asking each other out as a crush, etc. So all of these are kind of the results or the behaviors that they saw. So I mean, from a technical perspective, the architecture also was kind of quite important to me. Basically, like the way all of this work, and the way it can't just work with any model is the context length, which is like the biggest problem with large language models, because there is only a certain amount of memory that they can keep in mind before they start forgetting and start just coming up with random answers which are not relevant. So for that, they have something very specific. They have this new memory kind of architecture. So the first is basically the memory and retrieval module that they built. So for it, they basically have like so there are these three things. So like this kind of is the memory stream that I kept talking about, like the log that I talked about earlier, where if like every kind of object will say what it is doing at that time step. And then also the agents will also say what they're doing at that time step. And this is kind of how the other people will be able to observe it. And this will like continuously keep being generated as and when anything is happening. And this is like a very big memory stream. So all of this can't really go into the context of the LLM prompt. Like every time, if something is if LLM has to be queried about what they are doing or what the other agents are doing, they need the context of that. But we can't just copy this entire memory stream into the context. So for that, they have used retrieval augmented generation. Retrieval augmented generation is basically like a database for LLMs, where like if I have a normal website, we wouldn't just put all the information in the cached. Most of the information will be in the database, and you'll send an API call to query the exact information that you need, and based on the query, you will get a response back. So retrieval augmented generation works the same way, where all the natural language information, when it is a lot, is just put into this other database. And instead of being stored as natural language, it is stored as embeddings. And every time you need to query it, the query is also in natural language, which gets converted into an embedding. And then a similarity score is found between the two embeddings. Embeddings are just basically numerical vectors. And a similarity score is found between them, and based on the similarity score, the relevant document is retrieved, which is basically the actual natural language text that the embedding was formed from. So now here, like basically this is a memory stream that is there in a database, and if any agent is asked that what they are looking forward to the most right now, where right now is kind of important. So basically, what the agent does is makes this as the query, and queries this entire memory stream. And these are the three responses that the agent gets from its database of memory. Where the first is like that Isabella Rodriguez is excited about planning this Valentine's Day party, and then that person is going to order decorations for the party, and they're going to research ideas for the party. So basically, like these numbers here are these retrieval scores or these similarity scores, and based on those scores, like the highest score is becomes the answer. So this is the answer, and the agent basically curates a response based on that. So the like RAG is something very largely used with LLMs, but what this paper does is it defines three components that work together. Basically, RAG will try to match the relevance, and it is usually used for question answering. But in our world, in this world, the memory is kind of linear. So one of the things that matters a lot is the recency, or the what time this thing took place. Basically, there could be a much more interesting event, but that would have happened last week, so the agent wouldn't be looking forward to it right now. So which is why like recent events are important. So what this paper does is this retrieval score is actually made up of three components: recency, importance, and relevance. And recency is the score of like how on top, or how recently this observation was created, and they have like a decay factor for it. Then there is importance, which basically is like how important that thing is. So the way they get this importance score is they ask the large language model only, that every time they have a memory, they ask the model to kind of rate it and say what is the exact importance of it, or the score of it. And then there is relevance. Relevance is the basic RAG implementation. Like it is done by calculating the similarity score between the two vectors. And then what they do is they have a sum total of all of these, and they normalize it, and then they get the final retrieval score. So this is something that has worked really well. And then the other two great things in their architecture, one is reflection. It can be very nicely summarized by this diagram. Basically, there is memory, which memory is just comprised of observations, like this is idle, this person is doing this person is doing that. But what they do is periodically they ask these LLMs to infer reflections or infer opinions from observations. Like if there are a number of observations about Klaus Meller reading different things, the reflection that the LLM gets is that Klaus spends many hours reading. So basically, based on observations, the LLM makes these like own opinions about stuff, and those reflections also get stored along with the other memories. So when this retrieval part is working, it will not just get pure memories, like these are pure memories, but this would be something like a reflection. So basically both of these things would be inferred and queried. And yeah, and then so like they have like a kind of prompt for this too. They just ask the LLM based on these statements, get some insights. And then the last thing is like planning and reacting, where they encourage the LLM to kind of make like an exact plan, like for 180 minutes I will be doing this, I will be taking notes for my research paper, or for this much 1 p.m. to 5 p.m. I will be doing this. So then they, based on all their previous observations, they have a plan, and they always plan for the future. And like this is also like in their early observations, they realize that if they don't do this, the LLM will just repeat the same events again and again. Like it will have lunch at 12 p.m., it will have lunch at 1 p.m., it will keep having lunch. So which is why it needs to have an exact plan, and that tells it that it has finished lunch. So, and then the other thing was about how they update plans. So they have like an action loop, and if something there are perceived observations and there are pre-made plans, and at different times they prompt the LLM. So if at any point of time the perceived observation or the current observation says that your earlier plan is not valid anymore, then the LLM will just update the plan. So basically, it will be able to adapt to dynamic changes in the environment. And yeah, so and then yeah, this is also something that I talked about earlier. Like from the world environment, everything that is in the world environment is converted to natural language for the agents to be able to understand, and everything the agents do is converted back to the structured world environment. And they basically use like a tree data structure to kind of model the entire world, where they have like there's a kitchen, its child is a stove, and such. And yeah, they're like quite interesting paper. I won't go more, I think, into detail. They also got like pretty good results. Like their evaluation method was basically just asking them about different things, and also interacting using the user agent. And like the emergent behaviors that I talked about earlier were also like one of the big kind of results of the paper, that they were able to get all these very human-like behaviors out of the simulation. And yeah, so there are a lot of papers inspired by this one as well. One that I also talked about in my earlier blogs, which is called Humanoid Agents, and that is also that is basically it builds upon this paper and introduces system one thinking. So yeah, and also another thing that basically LangChain made an entire kind of implementation of this generative agents. Generative agents have their own code also on GitHub, but LangChain made a specific generative agent memory kind of thing. And what they do use in that is this time-weighted vector store retrieval, which is what I described, the kind of unique thing that they have, which is they are using both semantic similarity as well as this recency kind of metric. So the paper is well known enough for LangChain to kind of make this as well as they have a generative agents class also, and then anybody can now kind of use this very easily in their own projects as well. So yeah, I'll send the links.
All right, that looks great. Thank you. I had a few. Actually, I had a few. Jesse had a few questions in the chat. I had a few questions. Could you bring the paper back up? I wanted to see something.
Sure.
If you could go up towards the top, there was something in the second or third page I was interested in. But this is very good. This is actually. Let me go. Let's do this. Yeah, go down. Let's see. I think it was maybe relevant proxies of human behavior. Go up a little bit. So.
This one?
No, up further. I think maybe 2.1 or something. The believable proxies of human behavior. Yeah, so this is where they talk about believability and the prior literature. So this describes believability or believable agents, which are to provide an illusion of life, present a facade of realism in the way they appear to make decisions and act on their own volition. So it's like a representation of a human. So if you think back to the Sims game, they're sort of these simulations of humanity. The idea there was to simulate, and we've talked about SimCity and some of the ways that they did that, but in the Sims, of course, they simulate kind of like human behavior, kind of in the day of, a life in the day of type thing. So you have humans that are interacting, they're doing their thing, they're doing these rituals, they're walking around, and they're using a language that is kind of like a fake language or an ersatz language, but they have all these components that make you think, oh, this is like a human. This makes me think that this is like a human. And of course, it's not a human, but it's believable enough, which is, I think, is interesting that this is a way that people, and this has links to, of course, to video games as well, NPCs, and it has links to some of these things where we want to simulate something, and what do we need to simulate to make it seem like it's a good analog, or even that it's really kind of informative? Because a lot of the stuff in here is very much very cognitive science in the way they model human behavior. So this is a really interesting paper in that respect too. And in this other passage down here, moreover, more importantly, game worlds provide, right there. However, more importantly, game worlds provide increasingly realistic representations of real-world affordances. And as observed by Laird and Van Lent in 2001, these simulated worlds offer accessible test beds for developers of believable agents to finesse the agent's cognitive capabilities without worrying about implementing robotics. So this is reference to the Sarrah architectures and things like that, cognitive models. So this is really interesting with respect to that as well.
They've got some more paragraphs later, just next page on SOAR and stuff.
Oh, okay, yeah.
Yeah. So like a little bit further down. Yeah, starting there. Cognitive architectures.
Yeah, okay.
Yeah, yeah. For sure.
Icarus, yeah. So
Ather.
Yeah. As such, these agents were deployed mostly in non-open world contexts, such as first-person shooter games or blocks worlds. So, yeah, this is a great area, like, this believable agents or whatever. But to have like something where you can simulate enough of like cognition or human behavior, some social world, so that we think, okay, this is something that's approximating the way we behave. I think it's actually a very, very valuable thing. And of course, we can't, simulate everything about human behavior. We don't know everything about human behavior. But if we can get close enough, at least with some of these environments, and get an output that's like plausible, then I think we're making some progress, and we can learn some things from it, which we do from this paper. So.
Yeah, I think that this may, one, this paper got popular because a lot of us did play The Sims.
Yeah.
I liked it just because they, they're at the time certainly, and I think still, in terms of multi-agent, reinforcement learning, like there weren't a lot of examples of this kind of just open-ended experiments, right? Just putting a bunch of LLM agents together, tracking their history, and then seeing how well they did in terms of, carrying history, sticking to character, and things like what they described, I think, is their end-to-end text.
So yeah, and I like the parameters that they're using sort of for retrieval. So like, retrieval, of course we know from memory, there's this aspect of memory which is like encoding things, but then also retrieval and getting like those things out based on like their, recency and relevance. And, this is stuff we've talked about, of course, in Cognition Futures. So it's like, I think kind of thinking about it in those terms, we could maybe even update how we kind of build that memory kernel, saying, okay, well, if we want to have like, this is the way we can represent memories, or this is the way we can represent sort of retrieving behaviors from like something we store, or, we can actually kind of, build those new variables in addition to some of the things they highlight here, and kind of model that. So I think that's interesting from that standpoint, because we've been looking for methodologies for probing some of these things we've been talking about in Cognition Futures without getting too deeply into it. And we don't really have a lot of access to direct experimentation. For one reason is because we can't really, it's really hard to design experiments to look at those things. But in the other sense, we can do things with agents that we can't with humans and, non-human animals. So, that's another kind of methodology we might be able to use. So Jesse had some questions. So he said, so this base description and initial memory is inserted into all of the prompts and then updated, it seems, over time. So what's the relationship between prompts and the memory?
I believe, like, I've not exactly looked at the code this deep, but like what I believe is that so whenever an LLM is queried, they have like two types of prompts. One is a kind of a system prompt where the LLM is told what its role is. And I think that is where they're inserting the base description of the model. So they're putting it into the system prompt. And then there is the user prompt, which is the current prompt. And so basically, like as Jesse said, like the system prompt it's like appended to every prompt that is sent to the LLM, because that is like it's like it has to think like that person.
Mm.
So it has to be like kind of influenced. So I do think that is how it is being done. Or they could have just put it in the memory, but I don't think that would be working very well because the memory is based on recency, it would forget the initial prompt.
Mm.
Yeah.
Yeah.
So I don't know about the updation if they've factored that.
Yeah, it's very interesting, and I think this is kind of a follow up to Bradley's discussion. I'm not even going to go into it here, just because I want to. This is a much longer term thing, but like I think would be really interesting, not just how we mentioned about a number of qualities of the agents and ways to sort of, how lifelike or human-like is the agent. What I think will be really interesting to do a number of comparative testings of similarly structured agents, but like very different environmental or social affordances in the actual environments they're in. I think that's something that I would be interested in doing in the future, for sure. So.
Yeah. So then some of the other questions that Jesse asked. So Retrieval has reflections, which are synthesis of various observations that the agent has been exposed to. So Retrieval, there is an equation. I don't know if you can find it where they have the three parameters, and then so let's look at that in the context of this question. Right there.
Yeah. So retrieval is like based on the memory, but so what they're doing is like they have this memory stream. The memory stream has all of these observations, what they call observations. That is like they directly infer from the environment. Like every agent, kind of broadcasts it in a sense that they are doing this, and that becomes an observation. And then reflection is just kind of it's kind of just another prompt. So what they do is like they basically query the 100 most recent records in the memory stream and then prompt the language model saying that given only this information, what are the three most salient high-level questions you can answer about the subjects? Then this response basically generates some candidate questions. So this candidate question help like to understand what are the main kind of subjects and in this memory. And once they have these candidate questions, then each candidate question is again prompted as so, where like they again then query for the subject. So then they'll get all the statements about that particular subject. And then they tell the LLM to kind of what are the 5 high-level insights you can infer from the above statements. And then the answer to this kind of becomes a reflection. This is the reflection. And then what they do is this reflection statement, they again just store it in the memory stream. So then now when anything is queried about Klaus Meller over here, using these parameters, so the candidates won't be just these observations, but also the reflections. And so basically like that's how it works. First there is reflection, and then those reflection also get queried. And there's also, I believe, there's trees of reflections where like based on this reflection I had this reflection and so on.
Yeah. Okay, and then Jesse's third question was, I'd be curious about giving large language models personality features and also doing a version of this that is essentially a D&D campaign, also with motivations and narratives. So I think that's where they're moving towards here. They do mention things that are sort of related to that, and it would be interesting to see.
I say that out of the context of I think like I may have mentioned the Critical Role show here before, but it's essentially there's sort of what's interesting about Critical Role or there's many shows that are like recordings or streamings of people playing D&D. Critical Role is interesting because there's a bunch of professional voice actors, and they're also able to have a tremendously deep history with each other. So, just to background my forthcoming comment a little bit, Critical Role is really interesting because you have this huge interplay between what's happening in the game, like just the character. There's a strong commit to role playing. The human beings are totally make-believing their character in a game world, and there's these like very simple. There's this sort of representative artifacts like a game board or the miniature figures on the screen and rolling the dice. You have these like physical things, but it's almost entirely in the mind, But then you have the interpersonal connections between, when the DM's saying something or when someone's, discussing something, they're making a joke that the human understands. And then there's also this addition when there's like the Critical Role itself, like there's an audience, there's a local audience in the room, but then also this international audience, or there's this internet audience. So there's very like all these different layers of communication are on display at once. And I think it's really fascinating to think about from that perspective. Now, what I was saying here is like the D&D campaign. I'm not suggesting to incorporate all of that right now, because I think that's sort of a, that's a much more different layers of things and different, there's a Turing test and there's sort of my version of that with other things. But specifically for what a model like this could do in terms of the D&D campaign stuff would be like I could imagine scripting out this like set of things to go through, and in a D&D sense of, okay, this person had these motivations, or they start out this way, or like if people might be familiar with like Baldur's Gate series, because Baldur's Gate 3 is really popular right now. But like there's a character starts out with this background and then is iteratively changed by these different experiences over time, like getting to this. I'm kind of imagining creating these structures where someone gets to choose, like it's in Baldur's Gate 3, you have these like major choices that are like about alignment and how does someone like retrench their past history or make other choices. But what I'm getting at is like I'm thinking about this in the context largely of like plot twisters in the game that we're making there, and the dialogue and the reflection that's a major part of that too. And how do you sort of have these core memories in the inside out language, I suppose, versus these other things that are happening, and how, like, what is the consolidation mechanism? So thinking about all that in the context not only of an open-ended world that's like, hey, whatever, but also I want to kind of go back and think about like the other less open-ended worlds, or maybe less open-ended narrative, less open-ended structures, like the partially open-ended situation of a D&D campaign too would be interesting to flesh out. In some way, that's more that to my last point is like what's really interesting to think about there is the amount of open-endedness of the world versus the structure of what. If you're trying to do something educational or teaching or what message are you conveying in the nature of the open-endedness or not in that world. So that's a lot of interesting things to think about, and I appreciate going through the paper. So.
Yeah.
Well,
Yeah.
4.3 is definitely trying to get at those roles, that that kind of D&D role playing. Yeah, if you keep going down, right there, yeah. So it's talking about like what's realistic, what's unrealistic for the particular roles that they've given people, and in a rough way. Yeah, I'm kind of curious about the planning. How much planning there is. Like they do some good stuff with memory, but it is interesting. It would be unrealistic and uninteresting for an artist agent to plan on painting while sitting at a pharmacy counter for 4 hours without moving.
Yeah.
Right.
Yeah, this wouldn't
So-
be cognitive science and or robotics without some planning
Yeah.
in there.
Yeah. I'd love to see if the I forget the full name of this, but it's like the Winter School on Cognitive Models. It's like in India in kind of November, sometime October, November. Anyway, they cover like Actar and SOAR and all the all these things. I'd love them to cover this game.
Yeah.
Yeah, and like extensions to this game to add, kind of like what Jan LeCun was talking about in terms of his kind of 6 components.
Yeah.
Yeah. You remember, we talked about like we should get back to this, that in terms of how many of his components are in this, and how many still kind of need some implementation.
Yeah, about planning as well. Like, so what they do is basically they give like some information about the person, and what they do is they give like 1 day's plan. Like on February 12th, the person did this.
Yeah.
Now today is February 13th. Here is a similar plan, and then they just leave it here. And what LLMs do is they complete the earlier thing, and because it has like this earlier plan just there, it will like kind of be similar to it, and it will try to incorporate whatever is like some new information into it. So like it'll be very also regarding like even when Jesse said like be interested about like more personality features in terms of LLM. So like this is a paper, like Generative Agents is this paper, and then there's another paper called Humanoid Agents that basically like builds upon this as well. And what they've done there is they've added a lot more personality features, and they've gone right into like emotions and not emotions per se, I think, but more like things like self-esteem, or things like the basic needs and non-basic needs, and so like emotion and closeness. So all of these are like this paper like focuses much more on the agent, I would say, and like much more on their own personality and stuff. So this will also be like a
What is the title of this paper?
Yeah, if you could just
Humanoid
share it.
Agents.
Humanoid Agents.
yeah, sure.
Yeah.
So
All right.
We need the Serious Cybernetics Corporation.
Yeah. Well, thank you for that presentation. That was very good.
Yeah, that was awesome.
And so, just to finish up with, Sarrah provided some links here to the Wang chain site that she featured, the arXiv paper for the first paper, and then the arXiv paper for the humanoid paper, and then humanoid agents. And then Paola said, I had mentioned personality issues to Gemini just yesterday. It said it was open to analysis. And thank you, Sarrah. So yeah, I think there's a lot to follow up on this, and definitely more to talk about. So yeah, maybe we can do follow up next week on this too, and with maybe we want to talk about the humanoid agents paper or something else. This is definitely kind of food for thought going forward. Okay, so now I want to turn to this research management Slack channel, and I want to go over that because we were talking about that earlier. So this is the research management channel. This was something that we started on June 7th. So this was just something that was renamed. And so Jesse, would you like to talk about this a little bit, or? Okay, yeah, Paula gave a thumbs up.
Sorry, could you say that again?
Would you like to talk about this channel a little bit, or what you were getting at?
Yeah. I mean, there's sort of two different things. There's sort of like, and I'm not saying we need to change anything right now, but there's sort of the Originally, the channel was about discussing at a functional level, like it wasn't about like lab practices in our lab, or like doing research in our lab. But that's sort of what the later discussion came to be. Like a lot of the original posts are these conceptual things about like how do we talk about it, broader things to discuss, and sort of a component on mentoring, but then mentoring at a managerial level or other arranging conferences and things like that. And like, how do we do that? Blah, 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 blah. But then a lot of the discussion, which I don't want to get in the way of, but there's this talk about mentoring and doing the research documents, and Lucas appeared. So hi Lucas. Lucas DM'd me a while ago, but then I kind of attempted to further some conversation there, but I guess it came up here. And so there's sort of a little disparity about what like originally happened and where things are now, but like I'm not the things that people are talking about towards the later, more recent posts, like go ahead and do it. Like I don't want to inhibit anybody from doing things that they want to do. Like I think that's it's the conversations that are useful. People want to do that, they can. But there's sort of I want to find the right way to usher all of those things. So I'm open to hearing what we want to do and so on.
Yeah, I think this is a good, so, we've got a couple things here. We have like kind of this mentoring theme that we're doing with, we're doing Google Summer of Code, of course. We do mentoring kind of more generally with different groups that come into the lab. And then we, of course, have like people who are more experienced, say, in research, and people who are less experienced in research. And we can bring those people together. So, we've got that in a number of ways, not just research, but in like kind of topical areas as well. So I think that's useful to have that kind of mentoring relationship. And we haven't really, brought it together. And I mean, it kind of exists in the lab. And we kind of have a mentoring, not really a theme, but like we talk about it a lot. But having like, discussions about that is good, I think. And then, things like just things like talking about different topics in academia, different topics in professional development, which we do have a channel for professional development, but I don't know when that was last updated. That was, I guess, Jesse posts there, cross posts things. But this is, it seems like there's a couple of things going on in this area, but I think this is a good area. And I think about it in terms of research management. And yeah, Paola raised the point about having like peer mentoring, which of course, is when people want to do something like write a paper. We have people in the lab who've written papers. So it's like you can offer, some mentorship there. We have more structured mentorship like Google Summer of Code or some of our studentships that we've had in the past. And then, of course, our open source, where we're talking about these topics in open source, which is, hopefully people who don't have a lot of experience or exposure to open source will attend those meetings, watch them on YouTube and say, oh, yeah, this is really interesting stuff. There's a lot of stuff going on in the area. I had no idea. So these are all things that we can kind of build on. And yeah, I don't know exactly how, the question is how does this all fit into research management? How does it not? And I like to be inclusive about it. I like to say, if it's about research and it's about kind of making your efforts better in doing research, then that's what we want to get at. And it doesn't really matter how it kind of fits in a classified way. So yeah, this is great. And then let's see, Lucas had mentioned something about his interests. So Lucas is really, interested in doing things with research and kind of getting to the point of writing a paper. And he's expressed interest in that. We actually worked on a paper in DevoWorm together. So Lucas's comment, I think it's a great idea to start an initiative sub-channel under research management. Then everyone who would like to contribute can start contributing everything they know to Scholarly Paper 101 course Word document. For example, someone could start writing their own notes about some biology-related paper and how APA style works. And another person from a history background could talk about history papers in Chicago style. Little by little, we might have a bunch of resources and documents for people interested in scholarly papers. We could even get an expert like Bradley to write about biological analysis and how to run them. So yes, like different areas, you have different things that you do that sort of fit into the research banner. Like biologists do things that are different from physicists, from historians, philosophers, etc. But yeah, I think that's great. I don't exactly know how that would work. Like, you could have like things like collaborative papers. We do have that sort of already. And then of course if people have their expertise, they can lend it to that. That's sort of unstructured though. That it's hard to pull that off, and we need to kind of think about, like for example, Hussain has a paper that he's wanting to get collaborators on, and Paola is talking about being a collaborator on it. This is the ethical stimulation paper. And so, how do we organize all of our collaborators around that? That's something we need to work on, I think, and that would be a good place to work on it. But also, like having expertise, we could offer like tutorials in different areas. Here's how you do research. I could probably offer something to say about how you would build a pipeline, say in bioinformatics or something like that. Just as an example. I don't know how useful that is, but it's definitely something that could be, put out there as sort of like as some research or educational resources, and might be useful for people to think about. Okay, this is how you do this research. This is how I can implement things. Data analysis, the same thing. This is how I implement things step by step. Because if I just kind of do it on my own, I'm not familiar with the tools. I have to play around with it and make mistakes. And although that's good in some ways, it's also good to have like some guidance there and what the best practices are.
So and just to kind of bring about this, like another approach to this is sort of, or another commentary I'll put on sort of my, not quite headmaster, but like my curmudgeon-y senior like academic-y hat, and say this, like, well, also like, and maybe we don't stress this enough for people coming into the lab. We talk about like how to ORL or contribution guides, but like if you want to do anything or make a project, what I would suggest you do, you can mention it to us, like to Bradley or me or whomever you want to, but also a very standard base of it is mention it at our weekly meetings often. Like talk about it. Say, oh, I'm interested in the topic of, LLMs or generative agents. I'm interested in this paper this week, and I'm really interested in this space. And like you can just insert the thing that you want to talk about. And let me turn this off here. Sorry, I'll move away from the cooking sound. You can do that, and you can even like, if you want a place to talk about it in the Slack channels that you don't feel as there isn't one necessarily, you can do it there. Like I think to be self-critical for a moment, I think our Slack channels get in the way of this pretty strongly, because a lot of the Slack channels are links that people don't have any context for unless you're deep in the narrative and been paying attention for a while, and they're not. And I say this as someone who's the lab manager who's dealt with this for years. Like our Slack channels are not geared towards people developing projects. They aren't. We're not in the way of it, but the reality is the way that they currently operate, they're quite more diffusive rather than consolidating. And that's been a major issue. Like we don't really consolidate into, okay, let's continue to return to this thing, continue to return to this thing, continue to return to this thing and build it out into a project. Like that's just not, that has been heavily outsourced into an individual's own like willpower, basically. So I think without, if we don't, and I don't think that's the way it is or has to be. It's just I know that how things operate here tend to be more diffusive to that end.
Yeah.
So I think we need, like, I take it upon myself to try to say this as much as I can, but also offer that there are different ways to do it. So I think a lot of the merits of what the discussion that's happened in the research management channel is people, making these efforts towards, okay, well, how can we build out certain things? How can we build out certain projects? And I feel like I don't just want to say, oh, well, it's on you to do it and mention it here, but much more, it's an acknowledgement that we can do differently, if not better, but just differently ways of offering, hey, I'm interested in blank project. I'm interested in getting a paper together on this. I'm interested in moving the ethics paper forward. I'm interested in moving the cognition futures methods project forward. I'm interested in reviewing our, what's this? I keep hearing about developmental vehicles, and I looked around the GitHub, but what is that? I'm kind of curious about that. I don't know. Like those are things that can be brought up. So it's sort of this tension between, yes, it requires some impetus, but then also I think we can maybe do a better job of offering some structure, but then also one of the things that doesn't exist right now, and this is a slightly tangent, but also very much like lab admin thing, is we previously have had much more intentionally structured internship stuff, like summer interns or an internship program or an intern joining along with a project that's an established project, and kind of connecting those dots much more closely than they may have been now. Like a lot of people came through for the society ethics technology things in the past that presented ultimately at NICWIC, and that was I'm a little bit pained because I made an intentional choice not to do that this year, and there's not some of that structure right now. So it's I know that's, even if people aren't interested in that topic, seeing that structure in place in the lab kind of makes it a little bit, or not seeing it makes it more mysterious. Like, how does this happen? But I think there's things to be improved in that end as well. But I think to go back to the main point of this, it's sort of, if there's something that you want to do in a project sense, you're strongly encouraged to do so. And if you want specific mentoring on it, let us know. Either ourselves or connecting with other people in the network. We can try to do that. So I don't know if I'm sure you have a lot of things to follow up with that, Bradley, but that's sort of
I think part of the problem is that we put ideas out there and we don't you can grab onto an idea and work it out. And that's the part that we need to do to consolidate things. So if you, want to do something like do a programming exercise or write up a paper or a blog post, that's the thing that basically gets you to this consolidation aspect. It's we have this stuff in the channels. It's there. We sometimes go over it in the meetings, and it's there. But we can put it together in these artifacts. And this is one of the things that I've always stressed, is that you're doing these things not just as an exercise and showing off, but it's also just kind of to bring those ideas together. And if you just maybe write out 5 or 6 pages of a draft, or write out some code to test an idea, you can always edit it later and you can collaborate, but you have to start somewhere. And to start somewhere, you need an artifact to show people and say, this is what I'm thinking of. And I'm bringing together these ideas from the channel, and we're kind of putting our own mark on it. And that's where you need to be. That's what we need more of. And that's why I stress that, because it's just kind of hard to consolidate things otherwise. It's, it's kind of like the hidden back end of these channels. Like this is where we want to go with it.
It's we don't really use the phrasing demo or deploy or die here in an overt sense, but because there's sort of it's only so useful, and it's useful in the context of certain like productizing or showing to funders and investors. But I think maybe a slightly more applicable thing for our sense is the idea that there has to be the initial creation of an artifact. And I like that. That's language that I try to use, and those ones that I think I'm glad that Bradley used here too. But like the creation of the artifact itself, the draft, talking about it repeatedly, that's like where things come into like existence. So, and it's a tough and a weird process, but that's something that we encourage questions and interest and efforts about.
I think I don't know how much this will help, but like the fact that Jesse said about kind of a routine repeating of things. I've been part of a college lab before, a group where it was quite a similar structure. There were a lot of volunteer projects going on simultaneously, and the way that was kind of structured was so every time a project was started, a new Discord channel was built for it, and the relevant people were assigned roles. So then they would always get pinged for every message on that channel. And one of the things that I think helped a lot was there was a Discord bot that kind of used to ping every week, and it was just like a time for updates bot. So maybe if there is somebody who talks about an idea, and if there is maybe I don't know how Slack works in that respect, maybe a thread or a channel or something, and that way the people who had that idea can be kind of reminded to interact on it.
Yeah, we've done that. We have Slack bots that you can set up and do that, and it's very agile, like the agile project management style, where you're doing these regular reports, which is why you're going to do meetings every week to keep people on task. And but I mean, what I'm saying is that you need to start somewhere. You can assign people to something. They have to actually do something so that you have a frame of reference to move to the next step. And so that's good. We need to have we need to think about how we want to assign when we start a project, how we want to assign roles, and which people are best at what. And sometimes that's hard too, because it's hard to know kind of what people want to take responsibility for something, and maybe don't want to do it, or maybe they want to change what they are doing because maybe they're better at something else. It's kind of hard to get that right so that it makes it highly effective.
I do think there's for those who don't quite get my post, Slack bot is basically that's what we had when I first joined the lab. There was a Slack bot, and it was a simple what to do this week. It was the prompting is good, and then also the return of the Mac. But I do think what could be done, I think, and this isn't even we have done this before, but it's not an artifact set that we talked about. The contribution guide and how to RL, I think, could be updated with a bit of the insight of basically what Sarrah said, but explicitly saying, here's how you could go from an idea to a discussion channel, to a regular meeting, to a project, to a preprint, to a deliverable. Like making it very clear, what is our generic roadmap, a templated roadmap. I'm interested in generative AI, LLMs, and artificial agents interacting in environments or whatever. Here, what do I do? Okay, here's how you do it. You can join us. Here's an existing project we could potentially steer you towards, or here's a new space, and here's some people. Like just road mapping it out, because I think that's sort of the disparity between people who've been in the lab know that, and then us constantly, rightfully so. Like it's a very legitimate thing. Like we have to, when we bring people into the lab, that should be front and center. So, and I mean, Jen's not here, but we're doing like onboarding things that could be fit into that. So, good. Thank you. Also.
Yeah, even maybe I don't know if it exists already. I have not found it, but maybe a list of like all the active projects in the lab with like the people who are involved in it would be a good starting point.
Yeah.
I don't know if it exists already.
Yeah, we don't have like an archive of that at a very granular level. Like, I think the interns have done things, and like just like things that people have done or interest, even conversations and things like that. But
there's been many different attempts.
Yeah.
On websites and the old GitHub archive and everything else. So yes, that's yeah.
Well,
let's just say yes.
I have some thoughts about that, and I'll revisit that later. Actually,
yeah,
so
sure.
Yeah, I'd like to move on to next thing. So, thank you, Jesse, and Sarrah for that conversation. I think it'll be useful to. I'm going to share something here. I have an interesting statistical problem that I'm going to talk about here, and then I'm going to talk about kind of the solution that I'm going to present. So let's talk about this. This is Daniel Litt, who's a mathematician, a statistician, and he basically asked this question that had generated a lot of buzz. And sometimes when people ask questions like this, they're not really looking for an exact answer. They're looking for how people want to solve the problem and what the answer is. But you distill this down to a social media poll, and it's, you don't know why someone answered the way they did. So, there's the sort of initial question that's asked, and then in the replies you get like different solutions. And then you get this, kind of thinking about it and implementing your own solution. You kind of understand the problem better. So that's where we are with this. So remember that there's no right answers. There's no single answer to this, because we'll talk about some of the options later. So the problem is this. Let's flip a fair coin 100 times. And this is just coin flipping. So we know that coin flipping is this activity where you flip a coin and it lands heads or tails. And ideally, this is a stochastic process with the probability of heads being 50% and tails being 50%. So if we go, we think about this in terms of a set of states. We have heads, we have tails, those are discrete states. We have a coin that just gets flipped up in the air. And nominally, the probability for the transition here is, it's 50-50 whether you get heads or tails, where the probability of getting heads is 50%, the probability of getting tails is 50%. Okay, so you can think of this as like a finite state machine or a Markovian representation, which is here. And so this means that every time you flip, it's a 50-50 chance of hitting heads or tails. So one might think that, that being the case, that you end up with a sequence that looks something like this. So you have heads, tails, heads, tails, heads, tails, heads, tails, and so on and so forth, and that it repeats. But then when you actually do this with a coin flip, you notice that you don't get this. You get runs of states. So you get like heads, tails, tails, heads, 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 tails, heads, heads, tails. So that changes our probabilities here. So it's no longer, a 50% chance of heads, 50% chance of tails. Sometimes, if we we get these runs where it's like, sequences of the same state repeated. And this is actually quite common. And this is actually common in a stochastic process, or what we might call a true random process, because a true random process is not alternating between two states, because that's actually highly patterned information. When you think about a random process as something that's hard to predict, this is actually very easy to predict. And in fact, it's not random at all. It's heads, tails, heads, tails. So I could tell you exactly what the outcome should be. But this is actually truly random, and with a truly random pattern, you get these runs, but there's no characteristic length of the run, and they're interspersed within the sequence. So this is just a point that I wanted to make on this. So let's flip a fair coin 100 times. And it gives us the sequence of heads and tails. So you get this sort of quasi-random sequence that I showed you here in this box. And it's generated by this Markov process. For each heads in the sequence of flips. So what we're interested in are these runs, specifically these doublets or these runs of 2. So here I have a tails. And here I have a heads, and I also have a heads here, and I have a heads here. So we're interested in these runs of 2, okay, specifically. For each HH in the sequence of flips, and more specifically, we're interested in this heads sequence. So for each heads in the sequence of flips, Alice gets a point. So we have 2 players, Bob and Alice. Alice gets a point for each heads. And then for each heads tails, which are these heterogeneous states here, which are actually also, interspersed in the same way as the states that we have. So we have heads, tails, heads, tails, heads, tails. We have that in our sequence as well. For each heads, tails, Bob does get a point. So for the sequence THHHT, Alice gets 2 points and Bob gets 1 point. So you see, Alice gets a point every time there's a heads. And so we have a heads here and a heads here. So we get 2 points. And then in the heads, tails, which is here, Bob gets 1 point. Okay, we had a bunch of comments here. Oh, she can't see anything. Okay. All right.
I told her to just try restarting.
All right. So who is most likely to win? So that's basically our question. Who's going to get more points, Alice or Bob? And so if you think about these sequences, you think, okay, well, maybe there's a clear winner. Maybe we always get this tendency towards homogeneous states over heterogeneous states, or HH over HT. So Alice being the embodiment of these homogeneous states gets more points than Bob, who's is the embodiment of these heterogeneous states. So remember, we have Alice and Bob. We have, let's see, Alice being this person who gets HH, and Bob who gets points for this HT state. Okay. Now, there are other combinations, and we're going to ignore those for now, but we'll come back to that in a bit outside of the problem. So the poll was, who is most likely to win? Alice, Bob, equally likely, or see results, which let's not pay attention to that. Basically, more people think Alice will win because the runs of heads are more common than heads tails. Maybe that's counterintuitive, but that's what more people thought than heads tails being equivalent, or being more likely. And then the equivalents are equally likely. Most people actually thought that these would be equally likely, that you would get heads and heads tails. And if you look at this model that I showed you, I generated this kind of at random, that you get these heads and tails, heads, tails, and we have 3 and 3 in the sequence. Okay? So, I mean, yeah, you might think they're equally likely. You might think that Alice has the edge. Maybe Bob has the edge. Fewer people thought that. But that's a kind of, no one has the good answer here. And you wouldn't think so because that's a quasi-random problem. So that establishes our problem. So what happened here in this post was that people kind of came up with different explanations for this. And it depends on maybe your field or maybe your experience with statistics. So this is Joshua Miller. I haven't been on Twitter for a good few years. Nice problem. How does it connect to the hot hand? So we'll talk about the hot hand in a minute. So he's pointing out that Alice wins. Heads is more common than heads tails. And he shows some sort of a proof of this using conditional probabilities or Bayesian probabilities. So there's a Bayesian approach to this. And then if you do the Bayesian analysis, you find that Alice wins, at least according to this person. This is a response here. Again, someone points to what they call the hot hand fallacy. Using 3 coins tossing sequence as an example, given the previous toss is H, it follows T with higher probability 7 of 12. So, we can do this analysis. This person here says Monte Carlo, which is a technique for sampling random sequences, showing both as equally likely. So this is a Monte Carlo method. So this is where you're just doing this with like kind of a Markov model and generating a likelihood. And then this person, Zhou Shi, said it's conditional out of 8 possibilities, HHH, HTH, HHT, THH, and so forth. The first 6 have sequences HH or HT. So what this person is doing is they're generating triplets. And they're saying, okay, if you take the triplets and you sample them, then you get these sequences that emerge. And so you can count those up and get your answer. So there are a lot of, as I said, there are a lot of different answers to this problem. A lot of them have to do with the hot hand fallacy. And so let's talk about that. So the hot hand fallacy is something that I remember from like my first days in cognitive science where, I was really interested in the mathematical models. And this has a lot to do with kind of cognitive bias or cognitive social bias. So the hot hand is a statistical problem, but it's the way we perceive sequences of things in the world and random things and that sort of thing. So it has to do with like gambling and basketball and sports. So the hot hand, previously considered a cognitive social bias, is that a person who experiences a successful outcome has a greater chance of success in further attempts. So the idea that if you have a player who's hot in basketball, if they start making free throws consistently, you think that, okay, this person is going to keep making free throws consistently, even though they might be on one of these runs where they get, hits. And if you think of H and T as hits and misses, they can go on a run of hits. And, baseball is the same thing. You can go on a run of hits, and then you think, well, they're going to perform on a much higher level. But then they regress towards the mean, and then they start getting, they start missing. And it turns out that hot hand, where that hot is just kind of a statistical artifact of a random sort of performance. And that performance regresses to a mean, which describes their actual performance. So this concept is often applied to sports and skill-based tasks. It originates from basketball, where people shoot free throws or 3-point shots, and they do really well from time to time, and people think that that's a hot streak or a winning streak, and sometimes people attach superstition to it, so they like wear the same shirt every game to ensure that their player continues to be hot, those sorts of things. So where a shooter is more likely to score if their previous attempts were successful. So when you have the hot hand, you extrapolate out into the future and say this hot hand will continue. And so, but this is shown to be a fallacy because again, it's not anything that's inherent in the skill level. It's just this random sampling of a sequence of hits and misses and so forth. So this is where we're getting this hot hand idea. And so, moreover, evidence suggests that only a small subset of players may show a hot hand. And among those who do, the magnitude or effect size of the hot hand tends to be small. So that's consistent with this sampling of the sequence and how things regress to the mean. So if you sample a bunch of coin flips over 100 flips, you tend to end up with 50 heads and 50 tails. But if you subsample that at like 10, 10 flips or 5 flips, you see a bias maybe towards heads or tails. And that's perfectly normal for that kind of distribution. So this was first described in a paper by Gilovich, Tversky, and Valone, the hot hand in basketball paper from 1985. And this study questioned the hypothesis that basketball players have hot hands, which the paper defined as the claim that players are more likely to make a successful shot if their previous shot was successful. The study looked at the inability of respondents to properly understand randomness and random events, and so this is kind of thought of as a form of innumeracy, at least in the paper. The 3 researchers provided an example in which the study regarded the coin toss. Respondents expected an even short sequence of heads and tails to be approximately 50% heads and 50% tails. So again, going back to this, everyone expects this result up here. Heads, tails, heads, tails, heads, tails. That's sort of the intuitive choice. If you ask people, what's the outcome of flipping a coin 100 times? And they say something like, I'll get heads, tails, heads, tails, heads, tails 50 times. But that's not the way it works. If you do it empirically, this is what happens. That's not necessarily intuitive. So this is where this hot hand fallacy, or the gambler's fallacy, comes from. So, people have explained this in different ways. Sometimes it's confirmation bias. Sometimes you can think of it as a clustering illusion, so that, chance sequences can seem too lumpy to be something that's drawn at chance. So when you see 4 heads in a row, you think, that's a pattern. There's something there. There's something driving that pattern. When in fact, it's just an artifact of randomness or quasi-randomness. And so, this is, again, there's this other paper from 2018, Miller and San Giorgio, which I'm going to talk about in a minute. This is actually a new analysis of that original paper by Gilovich, Tversky, and Valone. And in contrast, concluded that there is significant evidence of streak shooting. So this actually says that there is streak shooting that occurs, and that there is a statistical basis for the hot hand phenomena. But, this is, again, one of these things that I've never really understood about this problem, is that, of course there's streaks, because that's a part of this quasi-random structure of a sequence of hits or misses or heads or tails. But, I think what they're getting at the hot hand is that when people see that, they think it's like something significant, when in fact it's not. So the streaks occur, but the way we interpret them is different. So you wanted to say something?
Yeah, is it? There's when we're done with this, I'll put on my controversial hat. Okay. But this is more of a clarifying question right now. Is because I think I kind of missed something, but is what we're currently I guess I'm trying to understand the relationship between someone, certain things are, I guess, random. Are people, is the message that basketball shooting percentage is random, or is it commentary on the sort of throw back to the observational I forget the name of the title we did a long time ago with Charlotte, but the role of the observer,
right?
Basically, the observer is identifying, okay, they hit 5 times in a row, they must have been really hot here, basically selection of sequence bias, yeah, as opposed to commentary on is it just commentary on the observing of the sequence from a sort of point view from nowhere kind of view, in asserting this is the asserting that there's something here, that they've been really hot here from the point of just looking at the data result, versus is that basically what it's attempting to comment on specifically, or is it commenting on, okay, I guess I've been a little bit distracted, so I apologize, but the basketball references are a little confusing to me as to are they saying there's nothing
is it commentary that, hey, people don't go on streaks in basketball, or like I guess I'm
Yeah,
a little
yeah.
confused.
So my confusing answer is yes and yes, and I'll explain what
Okay.
that means. So
Okay.
first of all, what they're describing is like if you look at a performance curve, that people tend to train and reach a level of performance that's sort of typical of what they can do. So like people will train and they'll get to a certain level of performance. That performance is characterized by some statistics, say like the number of shots that you make, and so that's like an accuracy percentage. And then within that accuracy, though, that's an average over time. Within that accuracy, you get runs of like success and failure, and so you can indeed go on like hot streaks that are like you hit a bunch of shots and then you don't hit a bunch of shots, but that's inherent in your skill level. But then when people look at the skill level and try to interpret what's going on, you can take an average over a long period of time, or you can take shorter averages and say, oh, they're definitely in a hot streak, that they're going to continue that forever, and then that's their level of performance. So it's like there's this sort of I don't want to say objective level of performance, but there's a sort of statistical summary of skill level at a certain point in time, and then there's like this shorter kind of what people are interpreting or extrapolating out from this point, from like local sort of information. So let me get on with this. So this is the Alice and Bob flipping coins puzzle. So this just kind of gives a summary of this post. And like many others, I intuitively assumed the answer would be Alice, since her winning segments can overlap, while Bob's can't. And yet the right answer is Bob. So now this is, according to this person, they come up with their own solution, which is Bob, which is actually not the consensus view at all. But to figure out this answer, let's represent the game as the following Markov chain. And so they map out a Markov chain as I did. They actually map it out a little bit more, in a little bit more complex way, where they model all of the states and the transitions required to make all of those states. And then we start at S1. Every time a coin is flipped, we move to another state. When we reach state 3, Alice gets a point. When we reach state 4, Bob gets a point. And so the question is, what are the probabilities that we assign to these transitions, and how do we reach them? And so then, according to this analysis, Bob is the winner. And so yeah, this is modeled in Haskell. So again, this is another thing where you're trying to interpret these, basketball shots or coin flips or whatever, and people are doing this in different ways depending on their type of analysis. This is actually the Miller and San Giorgio paper. So this is the one from Econometrica, and this is where they do the reanalysis of the original study. This is where, so the abstract of this paper reads, we prove that a subtle but substantial bias exists in a common measure of the conditional dependence of present outcomes on streaks and past outcomes in sequential data. So we're dealing with sequential data, and we're dealing with interpreting these streaks. And so in coin flips, it's going to be a 50-50 probability over a long period of time. We can take these short segments and interpret them the way we want, but those aren't really going to give us a lot of information. The same thing in shooting in basketball. You can make hits or misses. There's going to be a certain level of performance, but over short periods of time, we can observe these streaks. And again, they don't have a lot of information in them. But in this paper, they talk about the magnitude of the streak selection bias generally decreases as the sequence gets longer. So you observe fewer streaks, or, if you look at a short bit of a sequence, you get what clearly looks like a streak, but if you average it out over a longer period of time, the streak kind of melts away. But increases in streak length and remains substantial for a range of sequence lengths, often used in empirical work. So we get these streaks of different lengths. If you remember the stuff that we talked about with respect to avalanches and sandpile avalanches, where you get these avalanche events, and then they occur at different frequencies over long periods of time, and you get this distribution with different length scales. That's kind of the same thing too. It kind of comes from the same place. So we observed that the canonical study in the influential hot hand fallacy literature, along with replications, are vulnerable to the bias. Upon correcting for the bias, we find that the long-standing conclusions of the canonical study are reversed. So this is sort of taking on that original paper and kind of challenging their findings. And again, this first paper was Gilovich, Valone, and Tversky, and then this paper, Miller and San Giorgio, is sort of the partial rebuttal to that. But anyways, this is the attempt I made of this. I made this in Python and not in what they were using, Haskell, for this this blog post here. But I modeled this in Python, basically modeling these different states coming from a sequence. So I generated a sequence of doublets. So I have HT, TT, and TH, put them together, and then modeled this and extracted the states and saw how many times we ended up with our target states. So in this case, Alice wins 4 points to 3. In this sequence, we have to wait for the kernel to run. Alice wins 4 points to 3. And then this sequence, Alice loses 3 points to 1. Alice wins 3 points to 2. I keep running this kernel and I keep generating different random sequences. It extracts all of the doublets in that random sequence and then I count them up. And so as you can see, the answer changes each time you run it. So it's a quasi-random sequence. You extract the states, you count them up, and every time you run it, there's a different answer, a different winner. So Bob sometimes wins, Alice sometimes wins. So that's an interesting point. They didn't talk about this in the post, that if you run it again and again and you get these replications, that it's not replicable, that Alice sometimes wins, Bob sometimes wins. The other aspect of this is that, you can count things other than the HH and HT states, so you can model other states, and you get this distribution that changes over time, and you can now analyze this with information theory, and you get a different answer again with the different, every time you generate a new random sequence, you get a different answer. So I modeled this with a histogram, and it shows it's something interesting. From the runs that I did to build this histogram, it looks like if you do, I think, I don't know how many, 20 replicates of this, that Alice or the HH state occurs sort of in a random distribution. So if you look at this, how many times you get HH, and you look at the distribution of that over 20 runs, and then you look at the times that you get TH, or I guess this is TT and TH I'm looking at. For TT, there's a random distribution of that state occurring each time you run the simulation and you count up how many times it occurs. And for TH, which represents Bob, you get a much more restricted distribution. So, Bob wins sometimes, and Alice wins sometimes, but the distribution of those states over the 20 runs, for the TT state, it's actually normally distributed, and for the TH state, it's not. And so I don't know what that means. It might mean that you get these heterogeneous states that are not distributed in the same way as homogeneous states. I don't know. But anyways, that was my attempt at solving the problem, and it was different from everyone else's. And so my point here is that aside from the hot hand stuff and connecting coin flips to the hot hand fallacy, is that people, when you pose a question like that in statistics, people are going to solve it different ways using different techniques, and you get a different answer for all of them, pretty much. So that's what I had to say on that. I don't know, Jesse, you wanted to put your skeptic's hat on or your contrarian hat on.
I guess to put on that hat specifically, I will say from the point of view, like, and I'm saying this as if all the solutions I'm talking about are easy, and they're not. But I think some of it points out to, like, in our ways of speaking about both either, like I was thinking about
what's the percentage you make? Like in one particular framing, every shot, every time you made a basketball, attempted to make a basket in basketball, you only have two options, and it's you made it or you didn't. So it's always 50%. There's a 50% somewhere in there, depending on how you phrase things. Now, is that the same as flipping a coin? Not necessarily. What are the factors that change it? Skill level, and all these things about embodiment that we don't really talk about. Like we don't have good context for that. So and a lot of our general discussion about percentages and whatnot is like I think my unpleasant hat thing is pointing out I feel a little bit uncomfortable like Gary Marcus here, and I don't really want to, but just to kind of go there, I'll be like, we don't have great ways of conventionally, or even to some extent, like in a rigorous academic, we don't have the best ways of talking about all the factors that are at play. And even obviously in a conventional or layman sense, like the percentage of making the shot, or he's shooting 56% from the field today, he's shooting 80% field, and that's getting at some of the interesting takes on this is a relative, like climate versus weather, like hot in the climate sense, yeah, but hot, like it's a hot climate, like okay, climate more like an overall skill range. Like those are things that we sort of have these like weird ways of referencing in general, and some of it's bias related and everything else. But I guess my point is, and I'll let if Paolo wants to say something, I'll cut right to that. My point is basically there are ways to talk about things differently, and there's a lot of things that are, I think a lot of the work on many of these topics, and it goes back to phenomenology and everything else, is like, how do we reasonably account for in a really awkward and strange analogy, just like in the Sarrah's talk earlier today. Well, we have this base stuff that we're amending to every prompt that we send about the person, so that the system can, have this context for the thing we're going to parse. Like we don't necessarily have the best or consistent uses of that in a lot of these other spaces. So weird rush comment, but I'll turn it over to other discussion.
Yeah, Paula had her hand up.
Hi, can you hear me?
Yeah.
Okay, hi.
Hi.
So, there are lots of things I wanted to say, but I'll try to focus on the one quick point. So I'm not interested in statistics at all, and I was about to get off the call because it's very late there. But then, it's compelling. It's extremely important. Of course, it has to do with chaos theory, and obviously with randomness, and with a number of, it's just a good example. And I totally agree with Jess. I'm glad Jess brought this up. We're going to pick. We don't know maybe what we're talking about. So I don't know much about statistics or mathematics or knowledge that you presented, or how everyone is guessing and the code they use. But what I think I would like invite Bradley to reflect on, and maybe report in the future, if this reflection is useful, is what about, from where I stand, there is no randomness in flipping the coin. The only randomness is in our ability to flip the coin consistently from a physics. So, and this is a hypothesis. I didn't have proof of this, but if you flip a coin exactly in the same way, with the same force, with the same torque, with the same torsion, and the variables for Jess mentioned, I had the word variables in mind. So we don't know how the air density is in that moment, so how we try to factor that impact the coin flipping one way or another. And then if we manage to match them, and if we manage to replicate the flip exactly, I would argue that the randomness goes down considerably, possibly being able to flip the coin exactly the way we want to turn. And I don't know if this hypothesis has been made for already a pretty while, but for me, that's kind of a fact. And it's a little bit the challenge also that I mentioned it earlier when you brought up the avalanche. And I thought, well, really, we just don't know where the grain of sand is going to land, but that doesn't mean that there isn't a way to calculate it. It means you just don't have the algorithm. Similarly, for the basketball, I would be very surprised if there weren't a way of, I mean, if you build a machine that knows exactly how to replicate the throw where the ball goes in the basket, it's going to hit 100%. And I would be surprised if they haven't built a robot that can do 100% basketball. Because that's the first thing I would do. And then the question would be, is there any randomness in throwing the basketball? No, there isn't. The only randomness is in our ability to replicate exactly the same conditions and to map the variables. Is that clear what I'm trying to say broadly? And let me know if you or anyone has any thoughts about this.
Yeah, I think there's a lot to think about there, especially with like I get from you and Jesse that there's a lot in like a coin flip or a basketball shot that we don't really account for when we do the calculate the probability. So we say maybe if we can control, say, like the embodiment structure of a basketball shot or the minute physical details of a coin flip, could we bias it, or could we change it from being kind of non-random or something like that? And then you can actually see that with the comparison with this coin flip, which is sort of a 50-50 probability that we know from empirical observations, to something like a skill level, which is above random usually. So it's like if I shoot a basketball, I can make so many shots out of so many attempts, and that's a skill level. And then like that can increase or decrease between players or within a player over time. And then that's something that, if of course there's an embodied aspect to that. So if you're change, well, basketball players will change their shoes.
Yeah, and
or
also
whatever.
that doesn't mean.
Go ahead.
And that doesn't mean that there isn't randomness in the universe. But then the next question is that if we can control the flipping of the coin and the basketball, and apparently Toyota hands, I just found the link and posted it. So are there phenomena which are random outside our ability to control? Probably yes. Or maybe are we just not able to? I mean, I don't know. For me, the fundamental one is, does randomness really exist? Or is it our inability to understand how the universe works that makes it loose right random? I am kind of trying to think the second. So maybe one is just, I don't know, this is a very profound thing to ask. So I'm not expecting any answers. But thank you, Bradley, for considering it.
You're welcome. Yeah, and Jesse had a comment here where he says it's Hot Hand seems to have an uncomfortable relationship with embodiment and environment. Then it presents strange associations with anthropomorphism around sampling and sequences, and also the nature of how a selection process is done. And then there's an uncomfortability about like perception and force control. So yeah, there's a whole bunch of themes here that are sort of cognitive sciencey and sort of what's the term, epistemological. So
these definitely, I mean, like you said, these started as really attempts to understand cognitive biases, right?
Yeah.
Right.
Like, and so, when we've got incredible, the stats that people keep on sports performance are nuts. But the real question is, like, somebody's shot, three. I don't even know basketball terms to say this. So like, what's the penalty shot?
Free throw.
Anyway,
Yeah.
you know, and you ask people, you know, to bet on this person versus that person, right? Seeing that history, right?
Right.
They put more money on the person that's already scored, you know. And my reinforcement learning professor, Alan Nuringer, back at Reeds, he was focused on reinforcement learning of random sequences.
Oh, really?
So what he would do, you know, so what he was trying to get at was, if you try and press a random, you know, one or two, or, you know, head or tails,
Yeah.
right, and you know, to do that for you know, 100 presses, right, and then do information theoretic measures of those sequences, you know, the sequences that people generate. One, they wouldn't be random, right? So it's like a person can't replicate that temporal. It's the temporal sequence structure that occurs at random. You know, they end up doing, like you were, you know, showing, like the heads tail. Like I'll just
Yeah.
do it. You know, like a really simple uniform, but like that's actually really structured, right? And so his question, which is a kind of meta RL, actually, you know, was, can I reinforce you producing a random sequence? And he loved this, because I think his advisor was Herrnstein. But you know, in classic reinforcement learning, you should only be able to what is it? You're reinforcing something that should be deterministic. You know, like he was flipping it on its head, that you're reinforcing randomness, right? Anyway, so it's really just about that, or, you know, like the hot hand specifically, and then, like you said, like, what are your intuitions about what that's right?
Yeah.
I think it's somewhat interesting to think about neuroimaging statistics in terms of the spatial case, right? So, like when we talk about, you know, random field theory and how that's used for multiple comparison correction, it's really trying to take into account, like I know with Bonferroni, I know that you're gonna see, you know, 5% activation, or whatever you want to have as your threshold, by chance, if I've got, say, 10,000 voxels that I'm doing hypothesis tests. But I don't expect that those voxels, those random spots, will be all in a cluster, right? It should be like you know, and so these kind of cluster analyses that, again, like have interesting interactions with spatial scale, right?
Yes.
Which I think you're kind of seeing in the you know, the Monte Carlo simulations there.
Yeah.
With you know, 3 coins and, you know, etc. Like, anyway.
Yeah. Yeah.
It's conversation, and it's always. I mean, I always think about, like, when I don't like these problems, I always think about the Monty Hall problem and go, I should not trust my intuitions.
Yeah.
You know, even when I'm consciously trying to be Bayesian, I should recognize that, like, there's subtleties there that really can throw you off. Yeah.
So in the notebook, when I showed the sequences, that was generated by Python's generator. But the thing about generating random sequences is that we do this with a computer. We're approximating a random sequence. And people haven't really been able to figure out how to generate truly random sequences using a computer. So we're just approximating them. Yeah.
this is particularly close to home because my analysis thesis work was all on binomial mixture models.
Right.
So I was doing Monte Carlo simulations of these and then the multinomial cases, and yeah, it was all about these if we scan the same person say 8 times and then we do the processing of each 8 runs separately, but then look at the same voxel across those 8 runs, right? How likely is it that voxel is been labeled as active or significant?
Yeah.
And it was all it's all specifically about this.
A brief comment from me is going to be basically, I think there's a time when I turn into probability a lot more, and basically what Morgan was talking about, probability versus like spatial distribution, and how that like the embodiment influences on that. As I go, like I just no one like I guess I'm just in sort of a meta researcher, like something that I was never told growing up was we have a lot of authoritative speaking about very specific things in probability and statistics and machine learning and science and stuff now, relatively, but really emphasizing these aren't totally matured fields that have no more questions left in them and that are all like that. Like I feel like there was this presentation that things are super known and done and we don't have questions about this stuff anymore, and it's like it's just not the case. Like there's work to be done, and maybe there's an impossibility of it in the sense of what a human from a fixed perspective can comprehend.
Yeah.
Sure, but that's not the whole story. So that's I guess I'm like when I'm dealing with people, when I'm like doing people from like my other like from my university, undergrads from my alma mater, talk to me about stuff. Like that's really what I try to convey to them the most. Is like you're not just like radical, like oh yeah, you can think for yourself in like Dead Poet Society sort of way. Yes, that, but also like really this sort of rigorous and sober questioning of what the level of maturity of a lot of these things are and why and where are they in it. So it kind of goes back to frontier map stuff for me. Like I'm not I guess I'm not saying the word frontier map here or in many of my updates, but that's actually a major thing with JoPro that I'm still working on too. And sort of trying to, in one sense, you could say frontier map is an attempt to offer that context, or like how do you coming from nowhere, coming from very minimally information about something to get some of the context I'm talking about. So that's my closing soapbox for today.
Right.
But yeah, thank you for that.
Yeah, and then Paul mentioned that I would like to argue that randomness may not quite be what it is made out to be. We need work on understanding randomness. Yeah, and then Greg Chaitin, who's a mathematician, he did a book on exploring randomness, which is a great book. He's done a number of other pieces. He does a lot of work in algorithmic information theory and things like that, which are very close to understanding randomness and that sort of thing. So yeah, that's also good reading to understand. And yeah, we don't really understand randomness. Mathematicians do a lot of research on it in pure mathematics and applied mathematics. So yeah.
Yeah, and super important in terms of those Monte Carlo methods. Like the random seed generators and et cetera. Just really interesting points. So.
Yeah. All right. Well, let's leave it here. And thanks for attending, and thanks for putting things in the Slack. And talk to you next week. Thanks.
Okay.
Bye.
Bye.
Thanks.